All right, here we go. So I believe this is the final video for significant figures, and we want to talk about multiplication and division in this video using significant figures. And what we want to do is, for multiplication and division, our rule is round off the answer to the same number of significant figures as the smallest number of significant figures in any factor. So what do I mean by that? Well, let's just do an example and I think it'll become clear. What is the volume of a cube that is 34.49 centimeters long, 23 centimeters wide, and 15 centimeters high? Okay, so we're going to use this equation, volume equals length times width times height, to do this. So it's going to be 34.49 centimeters times 23.0 centimeters times 15 centimeters, okay? So when you put that in your calculator, what I got was 11,899.05. Okay, so when you get a number like this, that's considerably large, it's quite large, we should just be in the good habit of putting this in scientific notation to begin with. Okay, so let's do that. So kind of going back to last week's lessons on scientific notation or exponential notation, it's going to move this decimal 1, 2, 3, 4 places. And I can express this number as 1.1899905 times 10 to the 4th. And I forgot the units here before, but it's centimeters cubed. So centimeters times centimeters times centimeters. Okay? So that's my answer, and I want to express this with the correct amount of significant figures. And my rule for multiplication and division is that the answer needs to have the same number of significant figures as the smallest number of significant figures in any factor. So in other words, I need to go up here and determine how many significant figures each of these numbers has, because that will determine the amount of significant figures my final answer should have. And when I do that, okay, hopefully you have lots of practice doing this now. This has 4 figs. Okay, this has 3 figs. And this has 2. Let me move my screen a little bit so I can finish writing here. Figs. Okay, so this is the limiting factor. Because this only has 2 figs, that means my answer can only have 2 figs, right? Because it's the smallest number of significant figures. So I need to round this number to 2 figs. Okay, so we did an example like this already. This is going to be 1.2, because the 8, the first digit to be dropped, is greater than 5, so I round the 1 up, times 10 to the 4th centimeters cubed. Okay, there you go. All right, so that's how you do multiplication and division. So let's do one more example. Maybe we'll do a few more examples. We'll see here. And let's go from there. Take just one more example. Okay. How many hours are in 6.924 days? Okay, a weird amount of days, but this is a problem that uses dimensional analysis, right? So let's do that together. So it's all starting to come together now. So let's write down our wanted. No, I'm sorry. We do not want to write down our wanted. We want to write down our given. That's what I meant. We're given 6.924 days. Okay, we want hours. Okay, so our per expression, right? I know that there are 24 hours for 1 day. My path. So this is just to get us some more practice doing this. 6.924 days. Going to go to hours. And so I'm going to write that algebraically. Let me write it in a new color. Times for every 1 day, 24 hours. Okay, and when you put all this in your calculator, what I got is 166.2 hours. I'm sorry, actually, that's not what I got. I think I got 17 hours. Let me check that again with my calculator. Give me 1 second. Threw my calculator on the floor here. Let me just see. I was skipping ahead a step, I think. 6.924 times 24. Yep, 166.176 hours to be precise. Okay, should have wrote that down on my notes. I didn't, so I had to grab my calculator. Okay, again, is this the answer is correct, and is it expressed in the correct amount of significant figures? That's the question we're really trying to understand. So remember, with multiplication and division, we cannot have more significant figures than basically what we started with, the limiting factor, right? So this guy has 4 significant figures. Okay. How many sig figs does this have? The 24. Well, remember, if you go back, by definition, there are exactly 24 hours in 1 day. And exact numbers are infinitely significant, right? They don't have uncertainty. So they don't count. In other words, they don't limit the amount of significant figures we can have in our answer. So we're only limited by what we started with, which was 6.924 days, which had 4 significant figures, which means our answer can only have 4 significant figures, okay? So don't get confused there. It's not going to have 2 significant figures because of the 24 hours in a day. That's a number fixed by definition. It's only limited by the 6.924 days, or the amount of significant figures in the 6.924 days. So hopefully that makes sense. So this needs to have 4 significant figures. So round 4. Round to 4 sig figs. So this is going to be 166.2 hours, which is the answer I wrote to begin with, okay? Which I was skipping a step there in explanation. All right, so I hope that made sense, okay? So go back, review, look at the differences here when I'm using numbers that are from measured quantities like length, width, and height, like in the ruler example where I actually measured those. And here where I'm doing some dimensional analysis using numbers that are exact by definition, okay? So in the next video, I think we're going on to metric and US unit conversions. So see you there.